Hello everybody, and welcome to this video lesson about 3D modeling using SolidWorks. In this lesson, I'm going to discuss rules for 3D modeling. Rule number one, which I would like to call it the golden rule. In this rule, when you start 3D modeling, take care always about the shape first. Okay, roughly we sketch the shape of the model that we want to create. Then after that we apply constraints to control the geometry of this shape. So actually we are going to add sketch relations. Then after that is to add the dimensions in order to define the size of our part. Okay, so let's see how we're gonna use this rule during our modeling. Let's consider the following model. Let's say I want to create this model. Okay, so according to rule number one, the golden rule, I'm going to sketch roughly the shape of the profile of the front view. Obviously, to create this part, we need to sketch, we need to create this elevation view or front view, and then we are going to extrude it to this width. All right, so first we take care about the shape. So let's say this is our origin point on SolidWorks. So I need a center line actually, because obviously this model is symmetric about an axis that passes through the center of this part. So this is my center line, this is my axis of symmetry, and then roughly I will draw the profile. Don't worry about the dimension, don't worry about the size, just roughly sketch the shape of the front view, how it looks when we look from this side. Okay, so shape first, and then apply constraints, which means we are going to add sketch relations. In another word, what is the relationship between, for example, this line and this line? What is the relationship between this line and this line? Obviously, we need perpendicular relation, right? Also, I need this line to be aligned horizontally with this line. Okay, this line to be aligned horizontally with this line, and this segment is equal to this segment, right? So we apply, the sketch relations, and we're gonna have a separate video lesson about sketch relations. We have about 16 sketch relations, and we will learn how to apply these sketch relations, these constraints, in order to control the geometry of our model. All right, so remember rule number one, first we take care about the shape, then we apply constraints in order to control the geometry, then after that we apply dimensions in order to define the size of our part. Okay, notice that at these two steps all lines are in blue color. SolidWorks talks to you through colors, remember. So when the entities are in blue color, it means they are underdefined. We don't know maybe how far from the origin, we don't know how big is this line, and so on. So any entity that is not fully defined, it will be presented in a blue color. Okay, once we have sufficient information about these entities, it turns to black color, which means our sketch is fully defined. And this is actually the third rule in our modeling procedure. Okay, the second rule, so first rule, take care about the shape first, and then apply sketch relations, apply constraints, and then add dimensions. Never reverse this, please. You don't add dimensions and then you will be in trouble. Okay, rule number two, relate your sketch to origin. You must tell SolidWorks how far your model from the origin. Okay, the origin point normally will be displayed with the red color. Okay, while you are in the sketching mode, you will see this origin point. Okay, so you have to tell SolidWorks where is your model with respect to the origin. All right, so this is rule number 2. You never sketch somewhere here, we don't know how far from the origin, then your sketch will be in blue color. You will never get your sketch fully defined. All right, now rule number 3. Rule number 3. You don't do 3D operation. Never do 3D operation until your sketch is fully defined. Fully defined sketch. All right, so everything should be in a black color. Remember, when your sketch is in a black color, that means your sketch is fully defined. Fully defined means we have sufficient information about our sketch. Let me explain this concept maybe in SolidWorks. All right, so what does it mean we have fully defined sketch? To start a new sketch, very simple, I need to specify the plane that I'm going to sketch on it. We have 3 planes, mutually perpendicular. So front plane or XY plane, top plane or ZX plane, or right plane, ZY plane. Okay, so on which plane we sketch, this will be decided based on the given geometry. But for now, I'm going to select front plane. Once you click with left mouse button, you will see the context toolbar here. So from here, I can say sketch. I want to start a new sketch. Okay, how do we know that we are in the sketching mode now? There are a few things. Okay, when you see the origin point, the red origin point here, and you will see also the confirmation corner at the top right corner of your screen. And also here you can see editing sketch mode. So which means we are in the editing sketch mode. All right. So I'm here to explain the concept of fully defined. What does it mean fully defined sketch? Let us say we have a circle. Okay. The circle, any circle. So the circle now is in blue color. And here we have a message say on the status bar, it says underdefined. The sketch is underdefined. Why it is underdefined? We have few reasons. First of all, the size of this circle, the diameter of this circle is unknown, right? When I press and hold the left mouse button and drag the circle, I still can change its size, which means it is underdefined. So I'm going to add the diameter of this circle. Let's say I want to make it 2 inches. Okay. Now the circle still in blue color and the message here still underdefined. Our sketch is underdefined. All right. The second reason why it is underdefined, because this circle, we don't know where is it with respect to the 0 point. It could be here. It could be here, right? It could be here. So once I say, okay, it is this much, let's say 1 inch in X, and let's say it is also 1 inch in Y. Now the circle turns to black color and the message here is fully defined. So our sketch is fully defined, which means we have all the information, the necessary information about the circle. We know how big it is and how far in X, how far in Y. So that is what we mean by fully defined. Solid modeling functions. We have different ways that a user can create solid shapes. We have different ways to create solid models. We can use a primitive creation, Boolean operations, sweep operations, surface operations, engineering feature-based modeling, and parametric modeling. Okay, so I'm going to go through these methods quickly. Primitives are simple solids. So we have simple ready or shapes or models that we can use. So we have a block, for example, box, we have cylinder, we have a sphere, cone, wedge, and torus. Okay? They can be controlled by a small number of parameters and positioned using a transformation matrix. All right. For example, for box, I need just width, length, and thickness, height. Cylinder, I need radius or diameter and length, and so on. The second method to create solid modeling is the Boolean operations. Boolean operations are used to make more complicated shapes by combining simpler shapes. So, for example, we have three types of Boolean operations. We have union or join, we have intersection, and difference or subtract. So if I have cylinder and box, by combining the cylinder and box, I can get a new shape, new model, right? And by intersection of these two simple or primitive models, cylinder and box, I can get this model. And by subtracting this cylinder from the box, I can get this shape, okay, and so on. Also, we can create 3D models using sweep operations. Use 2D wireframe sections to generate 3D solid. So I create a 2D section, 2D sketch, and then maybe I can extrude it. I can revolve it to get a different shape. We can use a sweep, and we can use also loft. Loft, if I have different sections, say for example I have elliptical shape and then circular shape, rectangular shape, then we can join them with loft command. Sweep, if I have a constant cross section but it goes through a path, a certain path. All right. So if I go to SolidWorks just to explain this concept, maybe by so if I have this shape, the T-section shape, maybe we can, from this shape we can create different models. I can extrude it, either this direction or the other direction, to get this model, or I can revolve this section, the same sketch about this axis of revolution or axis of rotation, and then we specify the angle. Okay, say for example 180. Then we can get this model. So let me undo this. I can keep this sketch. Now let's go back to our presentation. Also, the other method to create 3D models is by engineering feature-based modeling. Okay, we have two types of features actually in SolidWorks. We have sketch-based features and applied features. Sketch-based features means we have to prepare a sketch and then just like what we did a few seconds ago. So we extrude or we revolve our sketch. The applied features doesn't need any sketch. Like for example, a hole. Okay, we don't need a sketch. I can apply the hole wizard, pocket, chamfer, fillet. These are applied features, so they don't need a sketch to create. Parametric modeling. Parametric modeling refers to the use of parameters such as constraints or relationships between geometric entities, as well as dimensions, the size of entities. These two types of parameters are used to determine respectively the shape and size of the geometry and hence the model. Parametric design changed the way products are designed and prototyped. So design, prototype, manufacture, all on computer. Parameters. 3D CAD programs use parameters to define a model of a design solution. Parameter is a property of a system whose value determines how the system will behave. Three types of parameters we have: geometric constraints, parametric constraints, and assembly constraints. Okay, so geometric constraints, these are a sketch relation, and they are non-numerical geometric relationships that the user assigned to sketch elements. So actually we use these types of constraints to control the sketch. So for example, we use parallel relation to make two lines, to force two lines to be parallel to each other. We use concentric relation, for example, to force two arcs or two circles to be concentric, which means they will share the same center. And also maybe making a line horizontal, force a line to be horizontal, or force a line to be vertical, and so on. So we will come to these sketch relations in the coming video lessons. Okay, these are some examples of the geometric constraints or sketch relations. So we have perpendicular relation, parallel, tangent, coincident, concentric, collinear, horizontal, vertical, equal relation, fixed, and symmetric. And like I said, we're gonna have a separate video lesson about these constraints or sketch relations. Parametric constraints are used to control the size and location of the geometry. So we have two types of dimensions. We have size dimensions and we have location dimensions. For example, width, height, this is the size dimension. But for example, location of the hole with respect to a given edge or line or whatever, so that's actually location dimension. Also may take the form of abstract algebraic formula, such as d2 times d0 divided by d5. Okay, we can create a relationship between the dimensions of our model. Parametric equations, okay, like I said, we can relate. For example, I want the width to be always equal to d2 times d0 divided by 5 plus 2 inches. For example, I want this dimension. So whenever we change anything in these dimensions, this will be updated automatically. Okay, as we shall see later on. These are the symbols that we can use in our parametric equation. So plus, minus, multiply, divide. Scenario: a child's proportions are similar to those of an adult. So for example, when we create a child a chair like this, the relationship between its sides or its dimensions, it will be the same actually for the adult one. So okay, we just need to scale it down. But the proportional dimension between these details are the same. Each dimension in SolidWorks is given a designation. Okay, once you create any dimension, it will be given a designation. Okay, so D0, D1, D2, D3, and so on. If we go back to SolidWorks, maybe, if you double click on any dimension, you see here, this is dimension number 4. So D4, D4 in sketch number 3, and so on. Any dimension actually is given a designation. So this dimension, this is D1 because it was the first dimension I add to this sketch. Maybe this one is D5 and so on, D5. So in SolidWorks, that's the procedure. Any dimension is given a designation like this. So D0, D1, and so on. Why parametric modeling? Okay, we use parametric modeling for the following advantages or benefits. Shape before size. So we take care about the shape. So roughly we sketch this shape and then we add the sketch relation, and then we take care about the size or dimension. Geometric and dimension constraints used to capture design intent. All files can be quickly updated. Anytime I can change dimension, just open the file and then edit whatever we want to do with dimensions and shape and everything. Existing data can be used for new designs. Quick design turnaround. That's all for this video lesson. Thanks for watching, and I will be talking to you very soon. Bye for now.